We are a project that indeed focuses on citizen science and participatory monitoring in data scarce and poor mountain regions. We've got 4 sites all over the world, Nepal close by here, Kyrgyzstan, Ethiopia and Peru. I will not go into much detail about the field sites and the actual activities that are happening there at the moment, because tomorrow you get 2 talks, respectively from Chila's work, who will explain the local situation in Ethiopia, and Deepak, who will do the same for the case study in Nepal. Instead, I'd like to use my 15 minutes here to give a little perspective on one aspect of the project, which I know is slightly controversial, but I think is a good opportunity to at least make you think a bit, and hopefully even create some active discussion, if not after my presentation, hopefully the rest of the day and today, which is the role of new technologies in an ESPA context. I'm an engineer. There's not too many here in the ESPA community, as far as I know. I've got a natural affinity with technology, but also working within an ESPA, in the ESPA context, I'm quite well aware about the potential controversial role that technology plays within and even further outside of ESPA. Quite fast here. I go back. Here we are. Indeed, we all use technology. Technology is inevitable to generate data, to monitor, to quantify the ecosystem services of a certain region. And of course, if we are to manage ecosystem services, it's quite crucial to know, to quantify them, to know how much resources they are, in order then to try and distribute and use them optimally for local development. But at the same time, technology, especially in a wider development context, still quite often has this connotation of also an enemy of especially development and trying to support local people, in the sense that there are, of course, quite a few barriers, and that technology can often be used to increase inequality because of the inevitable barriers in terms of financial, but also social and technological, should have been the third word there, and a natural tendency or a risk that is going to be monopolized by those that are more able to use technology, that have the intellectual capacity and the training to use technology. In a way, we often think about technology in the context of rich people leveraging it to get richer businessmen, gold and diamond encrusted iPhones, not directly the example of the most accessible technology. So essentially, there's really a risk. There's a very real risk that the use of technology widens the knowledge gap by empowering those that already have certain knowledge and using that and leaving out the poor, bypassing the poor, which essentially are those that the ESPA focuses on. But at the same time, whoops, technology. Shall we go back? Here we are. But at the same time, of course, as I already mentioned at the start, we need to use technology. We all use it in order to quantify, to measure things, to collect data. And when I wrote the abstract for this talk many months ago, I wasn't aware of this publication that actually came out a couple of weeks ago, published by UN, but commissioned from a group that calls themselves, you probably can't read it, but they call it the Data Revolution Group, that highlights the need to really get quantitative data, especially from regions where sustainable development is necessary. Actually, this discrepancy, this large imbalance in data availability is one of the things that holds back, that forms a bottleneck to sustainable development. And we do see indeed, even in terms of mobile phones, again, I was last week in our field site in Nepal, Upper Mustang, which is a quite remote area, but remarkable how many people use, for instance, mobile phones, remarkable how quickly that mobile phone coverage, the signal coverage is increasing, even in such remote and poor regions. Of course, it doesn't necessarily mean that everyone, especially those that we target, have mobile phones, but it shows that this is an inevitable change that we might as well try and leverage rather than being afraid and saying, "Ooh, we've got to be careful. We can't use that because it has a risk of being used for wrong purposes." And of course, ESPA is also about evidence-based, generating a body of evidence that can be used for decision making. So the more evidence we can generate, if we can use technology, it's a very powerful tool to generate quantitative and qualitative knowledge and evidence to support better decision making about ecosystem services. So really this balance between the risks and at the same time big opportunities that I think is a type of discussion that is well worth holding within the ESPA community. And of course, especially within this particular report from the UN, using data and using technology also to increase the openness and transparency is very important. Is something that UNESCO and others are strongly pushing as a way to decrease this imbalance between those that have access and those that have not, which of course is necessary if you are to increase things like capacity building. That is in a way the fundamentals or the fundamental idea of our project, Mountain EVO, really exploring these technologies and see whether we can indeed leverage them for very bottom-up and integrative ecosystem services management, participatory data collection, citizen science, interactive models of information exchange, knowledge co-generation is what we often call it, through what we call environmental virtual observatories, which basically is a way to leverage the availability of new technology, including web technology, cyberspace, if you will, to increase the generation as well as the dissemination of knowledge. But as I said, I won't go into too much detail. We're still in the quite early stages of the project, so far not too many results yet. The main output so far has been I think quite thorough and integrative review paper about all those opportunities and the theoretical as well and scientific challenges that the use of citizen science in an ecosystem services context might entail. So I'm very happy to pass you on the paper. It's of course an open access paper in Frontiers in Earth Science if you want to know more about the theoretical challenges. Instead, I'd like to just give you some examples of the type of technology that we are using. Not an exhaustive review, but rather just a couple of examples of particular technologies that we think within the context of our study sites might provide or might have a lot of potential to be used and indeed to make sure or to use technology for empowering the poor rather than excluding them. Here an example or just a quick review of what we're doing. So we're trying really to go to the local communities and from the start involve them in the monitoring, quantifying, generating data, generating knowledge about local ecosystem services such as water supply, biodiversity, etc. And I think that one of the things we realized very quickly is actually the type of data collection that you do is very different from what's often in classic science, especially classic natural science, has been done, where we're very much focusing on state-of-the-art technology, high-quality instruments, especially in hydrology, the requirement of having very long time series, 10 years, 20 years, in order to identify trends, etc. While in an ecosystem management context, often this paradigm needs to be turned around, and the best information or the most useful information is often short duration. You could argue that if you start collecting data, they are the first data, the first couple of weeks or months of your time series that generate actually most of or they have the highest information content. Not perhaps for very long time series and particular aspects such as climate change trend analysis, but to really characterize the resources that local people rely upon. And that's very important because that means that you can go for other types of instruments which are perhaps lower quality, less reliable, but you can, with the same budget, of course, buy much more of them. You buy 10 rain gauges, no worries if 1 or 2 or perhaps 3 fail, but you have the other 7, you can still use that to look at patterns, and you get a pretty good idea, even if not with 10 significant digits of how to quantify the ecosystem service. So instead of working with state-of-the-art monitoring and data logging techniques, which cost thousands of dollars, we use those very simple and very cheap things called Arduinos, an open source hardware platform, if you will, which costs around, this one is even cheaper than the 25 pound limit, but is around $20. It's at 12, 13 pounds, which is actually a data logger, very modular system where you can add easily things like data storage, Wi-Fi. Here's another one. This is about $50. In case you want to look, very welcome to approach me afterwards. But even includes a clock and a solar panel, a battery, and everything. So very cheap, perhaps not the same reliability of professional Campbell sensors of £2,000 each, but given that they are so cheap, you can easily buy many of them, and they will probably last sufficiently long to have a first characterization of ecosystem services, and definitely provide a lot of useful data to quantify and to get a good idea of what are now the local resources that people can rely upon. So modular, flexibly, and more than sufficiently robust in the context of quantifying ecosystem services for local use. Oh, now we're blocked. Can you perhaps see whether, yeah, that works. Here's another example. So we're focusing very much on water-related ecosystem services, because that happen to be, water resources happens to be one of the main bottlenecks in the regions we're working, especially Mustang in Nepal, very dry region. So you can easily build entire sensor networks. You can include SMS as a cheap way to transfer the data, bring them together in databases where you can process them, where you can add, link them to apps on mobile phones, etc. Yeah, further on, come back to that. And which again is an entirely, or an area that evolves very quickly, and that allows you to really collect a lot of data with very limited resources these days. Again, I won't go into the technical details. If you're interested, I'm very happy to explain them afterwards. So that in terms of data collection. But at the same time, this entire cyberspace or web environment that I mentioned, of course, has also an awful lot of opportunities in terms of data processing, visualization, and interaction with data. Here a simple example, an experiment we did by linking a rain gauge onto Twitter using Arduinos and basically creating, I'm not sure whether it's the world's first tweeting rain gauge, but this one is for now standing on top of our building in London. But basically every day summarizes the weather. You can see the precipitation as well as maximum, minimum temperature, etc. As an attempt to experiment with technologies and see how you can use them to really give people or make access to data much better than what is typically the case with traditional monitoring networks. You go even further. The project is developing a web-based platform for local NGOs that allows them to easily upload data. So a kind of web management platform, if you will, and tries to make automatic as much of the processing and data control that needs to be done. Yeah, and of course, in terms of visualization, you probably know more than enough examples of what you can do in a web environment in terms of interactive visualization. Of course, a lot of questions still to be solved, but for now, it's just a quick overview of what's possible as a way to think about and to be creative and whoever, and hopefully even get some feedback on ideas or even think about what these technologies might mean in the context of the projects that you're involved in. I mentioned mobile phones, of course, huge opportunity being featured in Nature quite recently, and definitely not anymore a technology that is restricted in terms of access. Even poor people these days often use mobile phones. Think about the penetration of mobile phone use in Africa. Okay, yeah, there we are. So to finish, a quick overview to hopefully raise some questions rather than give answers, but with the intention of creating a bit of a discussion about what new technologies might mean, what I mean in the context that you're working in yourself, Do you use any technology most likely for data collection and processing? Are you interested in improving user interfaces or dissemination or ways to make local people interacting with the data and the information that you generating? Then we'd be very, very interested to know about that and maybe even help thinking whether there are ways of using technology that we develop or that we are aware about in your project. And that's all I had to say. If there's time for any questions, I'll happily answer them.